All right, folks, so your lesson for today has to do with simplifying radicals. I know we've talked about this, we've dabbled in it a little bit over the course of the year, and now we're going to get really into it, okay? So you that have been answering some questions, trying to do the simplifying radicals correctly, you are going to have a leg up. You already are a step ahead of those who really clueless up to this point. So, but my hope is after today, you're going to know a lot more than what you already did, and I'm going to actually take you a lot further than what I'm going to expect from you on a test or quiz. And this might even be further than some of what you'll do next year in Algebra 2. But again, I want to push you a little bit and see what you can do, okay? So bear with me over the next couple minutes and then give your best shot on the rest of the worksheet here. All right, so if we get into this, the first thing I need you guys to know and understand is this. If I ever use the term radical, okay, that would be a reference that your parents would have used back in the day, back in the 80s and early 90s to say, probably more late 80s, to say it's something is cool, but it's also a mathematical reference to a square root, okay? So if I say radical, okay, radical 169, the square root of 169, it means the same thing, okay? Square root, okay? So I've already written out the rules for simplifying radicals for us. There's 3 of them we're going to cover today. The first one is this: no perfect square under the radical, okay? Now, what is a perfect square? Well, the perfect square is this. I can take the square root of any number, and if the end result is a whole number, we have what's called a perfect square. So for example, if I was to say, hey, class, what is the square root of 4? You would tell me what? You would say 2, right? What's the square root of 9? You would say 3. Square root of 16, 4. Square root of 25 is 5. All these numbers, 4, 9, 16, 25, they're all perfect squares, okay? So at the top of our paper, let's just make a list of this. Perfect squares. Okay, you're going to want to memorize these numbers here because they're going to be important. You're going to use them a lot this year, next year, and the year after that with your math classes. So perfect squares, we're going to go with 1 is a perfect square. It's not useful right now, okay? 4, 9, 16, 25, 36, 49, 64, 9, 81, 100, 121, 144. Let's see, what are the next ones? That was 12. 13 is 169. 14 is 196. And 15 is 225. Okay? So 15 squared, 225. Now, once you have those down, again, I said no perfect squares under the radical. I should add this, other than 1. Okay? 1 is the only one that's allowed to be there because 1 goes into anything, and so as a result, it doesn't help us to try and factor everything out, including 1, because 1 will always be there, okay? So as I take a look at, like, say, number 1, the first thing I do when I have a big number is I look at how, see if it's going to be a perfect square itself. So the square root of 169. Now, if you don't know how to plug in your square roots of a certain number into your calculator, you need to make sure that you've figured it out by asking a neighbor, okay? So square root of 169, it is a whole number, it's 13, it's a perfect square. We saw that actually back up here, right? Right there, okay, I just underlined it right there. So as a result, I'm done, that's all I have to do. It's a perfect square. Now, as I look at number 2, is the square root of 243 a perfect square? Dang it, it's not, okay? So what do? Well, I'm going to take this 243, and I'm going to start to look at what perfect squares might go into 243 evenly. Okay, let me put this up just a little bit more, cover more space here maybe. Okay, so as I look at this, I have 243. Does 4 go into 243 evenly? It does not. 243. Does 9 go into it evenly? It does. All right, so here's what I'm going to do. I'm going to write this down. 9 times 27 is 243. Now, folks, what's the square root of 9? Oh, it's 3. It's going to come out as a 3, okay? Now, as I look at 27, Is there a perfect square, any number up here that goes into 27 evenly? So right now I have 27. Does 4 go into 27 evenly? 27 divided by 4. No. Does 9 go into 27 evenly? It does 3 times. And so I'm going to write this down. 9 times 3 is still 27. I still have that 27 there. What's the square root of 9? It is 3. Okay? Now when that comes out, when that 3 comes out with this other 3, what do? Do we add the 2 3's or do we multiply them? Well, this is actually 3 times the square root of 27. When the square root of 9 comes out as a 3, that same multiplication that took place here, 3 times radical 27, is still there. So I'm actually going to multiply those 2 3's. 9 radical 3. Okay? So again, this square root of 9 came out as a 3. The 3 was already there. They multiply together. I have 9, and the square root of 3 just stays. Okay? Now, there was an easier way to do that because there's a bigger number up here in the perfect squares that go into 243. If I take 243 and divide by, I think it's 81, it is 3. So here's how you could do this even faster. If I took this number, the square root of 81 times 3 is 243. Well, what's the square root of 81? It is 9. So when it comes out, I have 9 radical 3. Okay? Now, how can I check myself? You may be asking. Well, I can go ahead and type in the square root of 243. It's approximately 15.6. You see that number already there. And if I type in 9 square root 3, I get the same exact number. Okay? So again, 9 square root 3 is the simplified form of square root of 243. Okay? Now, the next thing we're going to do, we're going to skip a couple of these, and let's go down here to number 6. Okay? Now, I'm going to multiply these two out. I can multiply them. I couldn't add them. Okay? One of the key things you might want to write down, this is really going to be crucial. I'm going to put this at the top of our paper here. Crucial as we move forward with simplifying radicals. It is this: treat radicals like variables. Okay? Treat radicals like variables. So I'm going to ask you guys this question. If this one and this one, they're not like terms, they're not the same. It's not the square root of 5 times the square root of 5. It's the square root of 5 times the square root of 10. So if this one was an x and this one was a y, could you multiply those two together? And the answer is yes, xy. Okay? Now, if I do the same thing, if this is an x, well, I'll go over here and show that in just a second. So I can multiply these together, and I get the square root of 50. Okay? Now, let me clear that out. If I go up to my perfect squares, and I start asking myself, well, first of all, is the square root of 50 a perfect square? No, it's not. Okay? We see that number 49, very close, but it's not a perfect square. So I start with 4. Does 4 go into 50? Let's see here. 50 divided by 4? No, it does not. 50 divided by 9? Nope. 50 divided by 16? Nope. Okay, now I'm starting to lose hope. Let's see here. 50 divided by 25? Oh, it does. 25 times 2 is 50. Okay? So if I take this, 25... hold on. Don't have much of an eraser here. Not 50 times 2 is 50. 25 times 2 is 50. Okay? Now, this 25, class, what's the square root of 25? That comes out as a 5, right? Square root of 25 is 5. And we have that right there. Okay? Now, if this is the simplified form, the square root of 50 should be the same thing as 5 square root 2, bada boom, bada bing, right? Okay? Exact same. So again, what's the big thing I want you to know? Treat radicals like variables. So we can take x and multiply it by y, get xy. But over here, in number 8, 4 radical 8 minus 2 radical 12, am I allowed to combine these two? Can you take an x minus a y? And the answer is no, we cannot. Now, what I would do first, there's several different ways to attack this problem, but this square root of 12 right here, if I go ahead and simplify that radical, I'm going to write this out. 5 radical 2, 4 radical, radical 8, we can simplify that too, okay? So, thinking back here, perfect squares, what number goes into 8 evenly? If you said 4, that's correct. 4 times 2, okay? Now, for 12, what number goes into 12? What perfect square up here goes into 12 evenly? 4 does, right? 4 times 3 is 12, okay? So what's going to happen here is this. I'm going to go ahead and take the square root of 4 and the square root of 4, and I'm going to bring them out, okay? Now, when I do that, when I bring those out, let me see if I can, there we go. If I bring those out, focus that a little bit. There you go. This is a 2. Remember, the square root of 4 is a 2. So what do I do with the 4 here and the 2 that's coming out? I multiply them. So this is going to be 5 radical 2. 2 times 4 is 8. And then this 4, square root of 4 becomes a 2. So this is actually 2 times 2. Okay. Now, if I could combine these two, I would do that. This is like 8x minus 4y. These are different radicals, so they cannot be combined. They have to be left separate, okay? So from here, I'm going to go ahead and distribute. I see the parentheses. I'm going to distribute that into the parentheses, okay? Now, I multiply the coefficients with the coefficients and the radicals with the radicals. The whole numbers with whole numbers and the radicals with radicals. So 5 times 8 is 40. Radical 2 times radical 2 is radical 4. 5 times 4 is 20. Radical 2 times radical 3 is radical 6. Okay? Now, looking back here, what's the square root of 4? It's 2. When it comes out, 40 times 2 is 80. Okay? Going back here, the 6, is there a perfect square from your list up here? Is there a perfect square that goes into 6 evenly? 4 doesn't. 9's too big. So my final answer here is going to be this right here. This is the simplified radical form. Okay? Now again, I can check that by doing this. If I do my calculator, I'm going to plug this in. 5 square root 2. Now you notice in mine I've got that parenthesis open. I'm going to close my parenthesis. Okay, some of you don't have the parentheses, but I'm going to close that there. And I have 4 square root 8 minus 2 square root 12. Okay, what is that? Approximately 30.01. If I do 80 minus 20 radical 6, 30.01. I have done it correctly. Okay? All right. Now, the next rule, I know we skipped to rule 3 because I think this is more important to cover here, and then we'll cover rule number 2. And these are taken from your textbook. So, no radicals in the denominator. Now, remember, your denominator is the bottom portion of your fraction. So, if I write this out, the square root of 28 divided by the square root of 2, okay, this down here is not allowed. I can't have that. So one thing I can do here is, I know that 2 goes into 128 evenly. So I can actually divide these out. So 2 goes into 128 64 times. So I've got the square root of 64. Now, in your head, it should be something, your spidey sense should be going off, right? It's like you've seen Spider-Man recently. There's something interesting about this. Square root of 64, what is that? Well, that's a perfect square. And if I take the square root of 64, I get 8. Okay? So just be aware of that. Be looking for that. If you don't get it, you can always start to factor some numbers out, but it is a perfect square. Okay? Now, let's drop down here to number 13. What should I do for number 13? Well, I've got two numbers here, and I can multiply them together. So let's do that. The square root of 18, 6 times 3 is 18, over the square root of 9. Okay? Now the square root of 9, 9 goes into 18 twice, so I could simplify this to become the square root of 2, okay? Now as you think about this, is there a perfect square that goes into 2 evenly? The answer is no. 4 is already too big, and so I'm going to leave it just like that, the square root of 2, okay? All right, now, two more. Actually, what I'm going to do next is this. Let's look at this. Let's do both of these. Square root of 45 over the square root of 2, okay? Now, folks, does 2 go into 45 evenly? And the answer is no. So what can I do here? Well, the next thing, the next technique, the next rule, the next hack that we're going to talk about in simplifying radicals, because I can't have this number down here, I'm going to do what's called rationalize the denominator. I'm going to get rid of that radical 2. So I'm going to go up here, put radical 2 over radical 2, and I'm going to multiply that by this over here. Now, if you think about this, what number is this right here? This is just 1. So am I changing this number in any way? No. But what you're going to notice is this. If I go ahead and take the square root of 2 times the square root of 4, what is that? I said that wrong. Sorry, let me repeat that. The square root of 2 times the square root of 2 is the square root of 4. Well, what's the square root of 4? The square root of 4 is just 2. Okay? In fact, whenever you take two numbers that are the same radical expression and multiply them together, you get that number out. So, for example, if I take the square root of 10 times the square root of 10, okay? Writing this down here. Square root of 10, square root of 10 is the square root of 100, which is actually 10. What's the square root of 7 times the square root of 7? Well, that's the square root of 49. Well, what's the square root of 49? It's just 7, okay? So if I take the square root of 15 times the square root of 15, what if I don't know what that number is? Does it matter? No, because it's just 15, okay? So whenever you take two numbers that are the same, you end up getting that same number, okay? So let's take a look at this. This ends up being 2. Square root of 45 times the square root of 2 is the square root of 90. Okay. Now, as I'm thinking about this, there is a perfect square that goes into 90 evenly. Okay, well, what is it? Well, let's start small here. 90 divided by 4, no, does not give you what we're looking for. 90 divided by 9, oh, there we go. We have 10. So if I do this, 9 times 10 over 2, what's the square root of 9? It's 3, okay? So I get 3 radical 10 over 2. Now, something to think about, this square root of 10, if I go back through my numbers, does 4 go into 10 evenly? No. Does 9 go into 10 evenly? No. Does 16? 16 is too big. So as a result, this is going to be my fraction. Now, you can either leave it like this. You could go ahead and do it like this. 3 divided by 2 is 1.5. You could do 1.5 radical 10. That would be fine. I think those are the two ways I'd prefer to be written out, one of those two ways. Okay? All right. If I go to number 15 down here, it's very similar to number 14. And so I'm going to rewrite this as a fraction here. 28 divided by the square root of 8. Okay? Now, there's a couple things to think about here. The square root of 8 has a perfect square factor in it. What number goes into 8 evenly? Well, does 4 go into 8 evenly? It does. And so this is actually going to end up being 4 times 2. Okay? Now, what's the square root of 4? It becomes 2. So this is 2 radical 2. Okay? Now, I can simplify this fraction. So what have we done so far? We just wrote it as a fraction. Okay? It's divided by, which is the same thing as a fraction. I simplified the radical in the denominator. Okay? And now I've got this right here. Now, what I would probably do next is I would reduce that fraction here. This ends up being 14 over the square root of 2. Okay. Now, I still have that radical in the denominator. What do I do with that? Well, remember, I can take this and multiply it by the square root of 2 over the square root of 2. If this number were the square root of 3, these would both be square root of 3 over square root of, 3. If this number were square root of 7, this would be the square root of 7 or the square root of 7, okay? It's always that number on top and bottom, and that's how you rationalize the denominator. Now, what does that give me? Well, what's the square root times the square root of 2? Remember, we talked about this in the last problem. It's just 2, okay? 14 times radical 2, what does that give me? 14 radical 2. This is like 14 times x is 14x, okay? Now, I can reduce this fraction right here. 14 divided by 2 is 7. And there's my answer for number 15, 7 radical 2. Okay. Again, if you're not sure, you're not confident, 28 divided by the square root of 8, 9.89949, and then 7 radical 2, 9.89949, okay? Oh, sorry, I thought those were both on there. All right, so again, they have to be the same when they're done. All right, I've got one last rule to talk through, okay? The last one is no fractions underneath the radical. So how do I make it so that I have no fractions underneath the radical? Well, the first thing I'm going to do is this. I'm going to rewrite this. I'm going to break apart the radicals. So the square root of 8 over the square root of 28, okay? Now, in doing this, I would probably try to simplify both of these radicals here. So in simplifying these, remember, 4 goes into 8 twice, okay? 4 goes into 28 7 times, okay? Now, the square root of 4 here is going to come out as a what? A 2, right? So this ends up being this, 2 radical 2 over 2 radical 7, okay? Now, these 2's cancel each other out. I'm going to get rid of that right there, okay? And actually, let's see here. Well, I could have actually reduced this fraction right from the get-go by dividing both these by 4 and gotten radical 2 or radical 7 as well. So I didn't think about that. I chose to simplify the radicals, but you can reduce this fraction right here to be 2 over 7, dividing both those by 4. Now, from here, I've got this radical in the denominator. I can't have that, so what am I going to do? I'm going to multiply both the numerator and the denominator by the square root of 7. Okay? Now, what's that give me? That gives me the square root of 14 over what? What's radical 7 times radical 7? It's just 7. Okay? Now, can I reduce this fraction right here? And the answer is no, because they are not both radicals. So I can't reduce that. The next thing I would ask myself is there a perfect square in 14? Well, does 4 go into 14 evenly? Nope. Does 9? No. And 16 is too large. So I'm going to leave it just like that. So one way to answer it would be like this. Another way you could answer it is this. 1/7 of the square root of 14. These are both the same thing. There's a 1 right here. You don't have to put it down if you don't want to. Remember, we treat the radicals like variables. Okay? So that's one thing you could do there. All right. Now, these next couple of problems, they get really technical. And so you need to make sure you pay real close attention here. Let's drop down to number 20 here. We might do 20 and 21. Okay? So for number 20, I'm going to write it like this. 5 square root 16 over the square root of 3. Okay? This one, I'm going to write it as the square root of 9 over the square root of 2. Okay? Now, the first thing I notice is this. What's the square root of 16? It's 4. So really, this is 5 times 4. I'm going to make that 20. Okay? I'm actually going to make a space here, because I see what's going to happen next. Okay? So minus, now we have the square root of 9 over the square root of 2. Now what's the square root of 9 become? That's just 3. Okay? So right now we have 20 over radical 3 minus 3 over radical 2. So what am I going to do next? Well, I've got this radical down here. what am I going to do? I'm going to rationalize it by multiplying by radical 3 over radical 3. Okay? This one over here, I've got this radical down here. I'm going to multiply it by radical 2 over radical 2. Okay? So what that gives me is 20 radical 3, 20 times radical 3, over radical 3 times radical 3, which is just 3. Okay? The numerator over here, minus 3 times radical 2, 3 radical 2. And radical 2 times radical 2 is just 2. Okay? Now, here's what I want you to know. This is 20 radical 3 over 3, 3 radical 2 over 2. Can I go ahead and subtract these two? The answer is no. It's not because they don't have a common denominator. We can make it a common denominator. It's because this right here and this right here are not the same. Okay? So as a result, they have to be left separate. So what you could do is this. If I took 20 and divide that by 3, that gives you 6 2/3. You could write it like this. 6 2/3 radical 3 minus 3 divided by 2 is 1.5, or 1 1/2. That's a possible way to answer it as well. Or you could leave it just like that. Okay? So, yeah, I'll leave it at that. Now, let's try number 21. Okay? So the first thing I'd check myself is this. Is there a perfect square that goes into 10? Does 4 go into 10 evenly? No. 9? No. And 16 is too large. So I'm going to leave it like this. 8 radical 10 over 1. Now, I'll show you why I'm doing it over 1 in a second. Okay? Now the next one, radical 40. Is there a perfect square that goes into 40 evenly? Well, radical 40 can become 4 times 10. Okay? What's the square root of 4? Well, it comes out as a 2. Square root of 4 is 2. And we have a 3 here already. So what do we do with the 3 and the 2? We multiply them. So this becomes 6 radical 10 over 1. Okay? Now for the last one, I'm going to write it like this. I could rewrite this last number right here like this. 5 radical 1 over radical 10. Okay? But what's the square root of 1? That's just 1. So I'm just going to put 5 over radical 10. Okay? Now, if I wanted to, let's see here. Let's work with this guy first. Let's go ahead and get this denominator out of there. How do I do that? Well, I'm going to multiply by radical 10 over radical 10. What does that give me? Well, that gives me 5 radical 10 over square root of 10 times square root of 10 is just 10. Okay? And I could take this a step further. It might make it easier in the long run. 5/10 reduces down to what? 1 over 2. So I've got this radical 10 over 2. If you want to put a 1 there, you can. You don't have to. Okay? So that was a lot of work there. You might want to go back and review that part. But again, I made this so it was a fraction. And then I went ahead and simplified what I had there. Okay? I rationalized it and then simplified it. Now, the rest of this, we have 6 radical 10 over 1. And we have 8 radical 10 over 1. Okay? Now, what's nice about this is that each of the radicals are the same. So can I combine them? The answer is yes. But before I can combine them, what do I need? A common denominator. And what's the common denominator between these denominators? It's going to be 2. So if I go ahead and multiply this number by 2, I have to multiply my numerator by 2. If I multiply this number by 2, I have to multiply my numerator by 2. Okay? So in the end, we have 16 radical 10 minus 12 radical 10 plus 1 radical 10. Now remember, this is the same thing as doing this. 16x minus 12x plus 1x. Okay, well, what would that give me? Well, that'd be 4x plus 1x is 5x. So this is actually, if we finish this up, 5 radical 10 over 2. Uh-oh, just broke my pencil. Guess it's telling me it's time to stop. okay? Well, 5 divided by 2 is 2.5. You can leave it like this. I'm fine with that. It's the same thing as this, 2.5 or 2.5 radical 10, okay? Now, again, that's a lot of stuff going on there. And so what I'm going to do here is this. I'm going to double check everything to make sure I've done it correct. And here's how I'm going to do that. If I type this in, 8, I'm going to type in the initial equation here, okay? So 8 radical 10, make sure I close off my parentheses, minus 3 radical 40, close off my parentheses, plus 5, square root, I got 1 divided by 10. I think that's how I would put that in there, 1/10. Okay, let's see what that is. 7.90569. Now, simplified form, 2.5 radical 10. Cross your fingers. Boom. Same answer. Okay. So, again, these on the back side, I'm taking you further than what you need to know for this class. Okay. Bonus type material, that's what I'm doing here. And so just to be aware, get that set, come on. Everything's backwards, I'm looking at myself. Just to be aware, I'm taking you further than what you have to know, all right? And so I want to see what you can do, challenge you a little bit. So I want you to finish up the rest of those problems for me for tomorrow, and not for tomorrow, I guess for Monday, and we'll come back and we'll take a look at it. Have a great weekend, folks. We'll see you later.